Welcome back to our online lecture series on textile effluent treatments. So in the previous video we saw about air pollution, then we also saw about properties of various air pollutants which are emitted into the atmosphere, and in this video we will be seeing about the methods of controlling air pollution, and we will also see about air pollution control equipments, and along with that we will see about ambient air quality standards. So air pollution control in stationary sources could be done by selecting suitable equipments such as air pollution control equipments. So the selection of such air pollution control equipments depends on environmental factor, then engineering principle, then economical factors, and also depends on the pollutant type which you are going to control. The extent of pollution removal, this varies with the technology which is adopted. And air quality management sets the tool to control the pollution emission. Okay, so we'll see one by one. So the mechanical devices set up or installed for controlling the air pollution emission could be classified into two types. One is the devices for controlling particulate matter, and the other one is for devices for reducing gaseous pollutants. So this control of particulate pollutants in industries could be brought about by the following devices. The first one is gravitational settling chamber, the second one is cyclone collector, the third one is venturi scrubber, fourth one is electrostatic precipitator, and the fifth one is fabric filter, or also known as bag filter. So first one is gravity settling chambers. As the name indicates, this method involves the principle of settling under gravity. So settling chambers use force of gravity to remove the solid particulate matter present in the gas or the air which is coming out from the any industry. So the gas stream first enters a chamber where the velocity of gas is first reduced, and next, as a result of reducing velocity, the larger particles drop out from the gas and it gets collected in the hoppers which are located in this chamber. So these settling chambers are effective for removing only larger particles, as it undergoes only under the influence of gravity. Only larger particles get settled in this process, and they are used in conjunction with many other efficient control devices. They are used along with other control equipments to get a better removal efficiency. So the minimum particle size which can be removed from this equipment is in the range of 5 to 25 micrometers. So the removal efficiency is lesser than 50% when using gravitational settling chambers. So here you can see the figure which shows you the cross section of gravitational settling chamber. So there is an enlarged section, enlarged chamber, and the exit is again reduced section. Okay, so enlarging and then it is converging. So when the gas is entering, due to the larger enlargement of the section, what happens is that the gas tends to fill the larger surface, and so as a result the velocity of the air get reduced. So then it is allowed to travel over a length of the chamber, and while traveling at a slower length it loses its larger particles, and such larger particles are collected here in this chamber. Okay, so then the dust which are collected in this hoppers can be removed when they are filled using a special valve provided, and the clean gas which has lost the larger particles comes out through the exit. So the next equipment is cyclone collector. Okay, so the principle of separation in the cyclone collector is inertial force. So we all know that everybody continues in its state of rest or motion unless it is altered by an external force. The same principle is applied here in cyclone collectors. So here the gas is allowed to follow a circular path by in a circular chamber, and as a result of its motion in circular way, it loses much of its particulate matter. Okay, so let's see it. So it uses the principle of inertia separation, and here we force the particulate matter laden gas to change the direction. So when the gas changes its direction, the inertia of particles tend them to move in the previous direction itself, right? So it won't change the direction suddenly. So since the direction of the gas is changed suddenly, the particulate matter are separated from the gas stream. So the walls of the cyclone separators are narrowed toward the bottom of the unit. So this allows the particle to get collected at the bottom hopper. The cleaner air leaves through the center of the chamber. So in the top of the chamber, the cyclone separator, the clean gas is collected out. Okay, so here a spiral vortex is formed during motion, and this gives you the spiral movement. So the cyclones are efficient in removing larger particles but are not as efficient with smaller particles. And for this reason, they are used along with other control devices. So the minimum particle size which can be removed here is less than 50 micrometer, and here the removal efficiency is between 50 and 90 percentage. So here you can see a diagram of the cyclone separator. Here it is nearly conical shape, and the gas is allowed to move in a circular motion. So as the gas moves in circular motion, it loses much of its particles due to the inertia force, and the clean gas comes out. Okay. So next comes Venturi scrubbers. So Venturi scrubber uses liquid stream to remove the solid particles. So here the particle laden gas is passed through series of liquid. Okay, so here it is passed through a short tube with flat ends and a constricted middle. So this constriction causes gas stream to speed up when the pressure is increased. So the difference in velocity and pressure results from the constriction causes the particles and water to mix and combine. So this constriction allows them to mix and combine. So this reduces in velocity at the expand section of the throat. This allows the droplets of water which contains the particles to drop out of the gas stream. So here the minimum size of particles that can be removed is less than 0.5 micrometer, and the Venturi scrubbers are effective for removing small particles. So it is effective in removing the small particles also, and here the removal efficiency is about 99%. So it is a good method, but however here is a disadvantage that there is a production of wastewater, and we need to find out a method for disposing this wastewater. That is a drawback in Venturi scrubbers. So the production of wastewater is a drawback in this case. So here you can see it is similar to a cyclone separator. We can see wet cyclone separator. Here you will spray water and you will allow the gas to pass through. That's the one method. And so this injection allows the particulate matter to get mixed with the water and it gets separated. So next is electrostatic precipitator. So here this uses electric charge, electrostatic energy for removal of the particles. So normally smaller particles, so when the particle size is smaller, they possess a certain residual electric charge. Okay, so when we imply electrodes and pass electric current, we can separate the smaller particles very efficiently. So such principle is used here. So this is a control device which uses electric forces for removing out the particulate matter. Okay, we use certain collector plates which are charged in nature, and depending on the charge of the collector plates, the opposite charged particulate matter gets stick to this collector plate. Okay, so the particles are removed by wrapping and collected in hopper located below the unit. Wrapping is nothing but smaller movement which we provide on the collector plates, and they lose the particulate matter, and it is collected in the hopper which is located below. So here the removal efficiency is highly variable, and we can see that very small size particle which are less than 1 micrometer could be removed here very easily. The removal efficiency here is 99%. And this particular electrostatic precipitators um, are not only used in utility application but also used in many industries where particulate matter is rich in the exhaust gases. So it is highly used in thermal power plants. It is used in petrochemical industry, and it is used in steel industry, in pulp and paper industry, in many exhaust gases which carry high fine particles. This method could be easily employed. So you can see the diagram here. So the plate may be circular, and in the plate we pass the electric current. So dirty gas is passed through the bottom and clean gas is collected through the top. And while passing through this collector tubes, charged collector tubes, the particulate matter possessing opposite charge get attracted to the tubes, and the clean gas comes out. So once the gas is removed after the process, this the particulate matter could be removed by um, flapping. That is nothing but we are shaking the tubes so that the particulate matter comes out, and we can collect those in the hoppers which are provided at the bottom. Okay. So next is fabric filter or bag filters. So they are used to remove the dust from gas stream by passing through a fabric filter media. Okay, the filter medium is the fabric filter, porous fabric, and it is efficient in removing fine particles. And here the efficiency is about 99% in most of the application. So the selection of fabric filter material and its construction is the important factor here in baghouse performance. The fiber material from which this fabric is made must have an adequate strength so that it can withstand the high gas temperature. Okay, so here the temperature withstanding capacity of the fabric filter is an important matter here. So we should choose a fabric filter such a way that our fabric doesn't get damaged in the operating temperature. Okay, that is the only disadvantage here. And the minimum size of particle that can be removed is less than 1 micrometer. Okay, so this is a typical diagram of a fabric filter. So series of fabric filters are placed and gases pass through them, and clean gas could be in an enclosed chamber. We pass through fabric filter and clean gas is obtained to the other end, and the deposited particles could be collected at the bottom of the baghouse or fabric filter unit. Next is control of gaseous pollutant in industries. So industrial gaseous pollutants can be removed by adsorption or absorption, condensation or combustion, and incineration units. So any of one of the methods could be adopted, or they can be used in combination. So in absorption units, the removal of one or more selected components is by the process of absorption. So absorption is process where gaseous pollutant is dissolved in a liquid. Okay, similar to a Venturi scrubber. So as the gas stream passes through the liquid, this liquid absorbs the gas. So in the same way that sugar is absorbed in a glass of water, right? So the absorption are often referred to as scrubbers. So absorbers are commonly referred as scrubbers. So Venturi scrubber is a common type of absorption unit. So this can be also used for removing gaseous pollutant, also Venturi scrubber. Okay, the principal type of gas absorption equipment includes spray tower, then packed column, and then we have spray chamber, and we have Venturi scrubber. So absorbers can achieve removal efficiency greater than 95%. And as the same case of Venturi scrubber, since it also comes under absorption unit, the disadvantage is that generation of wastewater. Okay, so it transfers the air pollution problem to water pollution. So here we'll have an absorbing column. That may be a packed column, or we may spray the gas or spray the liquid over this passage of gas. So that's maybe spray tower or plate tower or packed tower. And while the gas passes through the liquid, it transfers the pollutant to the water and clean gas comes out. Okay, that's the mechanism here as the same case of Venturi scrubber. Okay, next is adsorption unit. Okay, so when here adsorption property is used of. So by weak physical forces, the gaseous pollutants are attached to the adsorbent. So when gas or vapor is brought in contact with a solid, some part is taken up by the solid. So these molecules disappear from the gas, either enter the inside of solid or remain outside. When it is present outside, it is called adsorption. Okay. So the most common industrial adsorbent which are used are activated carbon, silica gel, alumina. So they have enormous surface area and those are activated sites for attachment of pollutants. So the activated carbon is commonly adopted everywhere for purification and removal of organic contaminants from both liquid and vapor streams. So the carbon adsorption system can be regenerative or non-regenerative. So this regenerative system usually contains more than one carbon bed. So when one carbon bed actively remove pollutants, the other bed is regenerated, which can be used for future use. In non-regenerative system, they have thin beds of activated carbon. In non-regenerative absorber, the spent carbon is disposed of when it becomes saturated with the pollutant. So here you can see the typical diagram of a regenerative carbon bed. So we pass steam for regeneration on one side and we remove gas to the other side, or we use two separate carbon beds. In one we will carry out regeneration, in the other we'll carry on the uh, adsorption technique. Okay, so once the process is over, we'll change the carbon bed. Okay, we'll change to the other bed, other column, and in one column we'll carry out the regeneration. This is carried in a cycle. Next is condensation units. So condensation is conversion of gaseous vapor to liquid. So here we lower the temperature or increase the pressure and convert the gaseous vapor into liquid. So condensers are usually used as pre-treatment techniques. They are used before absorbers or absorbents or adsorption process or incineration, so that we can reduce the total gas volume. So it could be easier to treat and it reduces the treatment expense. So condensers used for pollution control or contact condensers or surface condenser. So contact condenser in is where the gas comes out in contact with cold liquid, while surface condenser is where the liquid and the solid doesn't liquid and the gas doesn't comes in contact. They are passed in the surface of the condenser. Okay, so that the coolant is passed on the surface and as a result the gas gets condensed inside the tube. So here the removal efficiency of condenser is in between 50 to 95 percentage, and it also depends on the design and application. So you all know the condenser. You can see a condenser in a chemical lab where there will be an facility for passing coolant in the outside of a inner tube. So in the same way here you can pass the coolant liquid outside the gas tube which is passing inside. The same way happens here. Okay, incineration units, next one. So we can also incinerate the gas when it contains high quantity of volatile compounds. Okay, so organic compounds if present could be treated by incineration method. So this method uses rapid oxidation of the substance using combustion technique. Okay, so we use oxygen and combustible material present can be removed by this method. When combustion is complete, the gaseous stream is converted into carbon dioxide and water vapor. So the equipment used for control by combustion methods are direct combustion or flaring. The next one is thermal incineration and catalytic incineration. So direct combustion is a device in which air and all combustible waste gases react with the burner. So here complete combustion occurs instantaneously and there is no residence time. So once there is a contact of gas with the burner, the reaction takes place immediately. That is, the combustion takes place immediately without any delay. So a flare can be used to control almost any emission stream containing volatile organic compounds. So by some studies conducted by the EPA, the Environmental Protection Agency of USA, have shown that the destruction efficiency of flare is about 98%. So the efficiency here is 98%. So next one is thermal incinerators. Here the combustible waste gases passes over or around a burner flame into a residence chamber. So a residence chamber is provided here where oxidation of waste gases is completed. So once completed, then they are passed to the next chamber. So thermal incinerators can destroy gaseous pollutants with an efficiency 99% when the operation is carried out correctly. Okay, so you can see a process diagram for this combustion. So auxiliary fuel and air is passed through a combustion chamber, then it is taken to a waste gas preheater, then it taken to a secondary engine recovery. Okay. So next is catalytic incinerators. So they are similar to thermal incinerators. Here the main difference is that after passing through the flame area, this gas is then allowed to pass through a catalytic bed. So we use some other catalyst, so catalytic bed, so that complete oxidation is ensured here. So this catalyst promotes oxidation at lower temperature. So it reduces the fuel cost. So here the destruction efficiency is greater than 95% when using this catalytic combustor. So here you can see catalytic incinerator flow diagram. So in the combustion chamber we pass auxiliary fuel and air, then it is taken to catalyst chamber, and after catalyst chamber it is taken to waste gas preheater where we pass emission source and dilution air. From there it is passed through energy recovery, then it is taken to stack. So next is ambient air quality. Ambient air quality refers to the condition or quality of air which is surrounding us. So those air which are surrounding us, their condition is referred in terms of ambient air quality. So the national ambient air quality standards are set up by the Central Pollution Control Board, and it could be seen in its website cpcb.nic.in. Okay, and it is applied throughout our nation. So the CPCB has conferred this power by Air Pollution Prevention and Control Act of 1981. So the ambient air quality standards in India came into Act in 1981. So I have given the link here. You may see the link. As so it was enacted to check the deterioration of air quality. Okay, so this Air Pollution Act has given some functions to the Central Pollution Control Board. So it can advise the Central Pollution Control Board can advise the central government concerning any matter for improving the air quality and for checking the pollution of air and control. So, and it can plan and cause and execute nationwide program for prevention and control and abatement of this pollution. It can carry out and sponsor investigation. It can collect and compile, publish technical and statistical data related to the air pollution, and it can announce any standards by its own. So those powers are conferred to this CPCB. Okay. So you can see the National Ambient Air Quality Standards. So for pollutant, sulfur dioxide, annual concentration can be in an industrial area or residential area. It should be 50 microgram per meter cube, and in ecological area it should be 20. In for 24-hour value 80 and 80. Nitrogen dioxide, the concentration annual is 40 and 30, and for 24 hours it is 80 in the both cases, ecological sensitive area and residential and industrial area. So particulate matter 10, which is size less than 10 micrometer. The annual concentration should be 60, and 24-hour concentration should be 100, within 100. For PM 2.5, the annual concentration is 40 and 24-hour concentration should be within 60. And ozone, it is given in 8-hour and 1-hour concentration. 8-hour concentration should be below 100, and 1-hour concentration should be up to 180 microgram per meter cube. And lead's annual concentration is 0.5, and 24-hour concentration is 1 microgram per meter cube. In the same way, carbon monoxide is measured in 8 hours and 1 hour, which has 2 and 4 respectively. So in the same way we have ammonia, benzene, benzopyrene, arsenic and nickel, which are represented in the National Ambient Air Quality Standard. You can go through it. Okay, so next is National Air Quality Index. In the same way as ambient air quality standard, air quality index is used to communicate to the public how the air is polluted. So it is a chart or index to for us to understand how our air is affected due to pollution. Okay, so it is represented in colored form, and it is given as good, satisfactory, moderate, poor to very poor, and severe. So it is ordered in this wise, and the breakpoint for each AQI scale is given in this table. Okay, so for particulate matter 10, in 24 hours variation, for particulate matter 25, the range is given, and they are classified in the way such that 0 to 50 is given as good, 51 to 100 is given as satisfactory, and 101 to 200 is moderate, 201 to 300 is poor, 301 to 400 is very poor, and above 400 it is severe. Severe air pollution is present. Okay, severe contamination of this pollutant is present, and these are concentration in microgram per meter cube. Okay, so when air quality is good, it will have minimum health effect, and when it is satisfactory, it will cause minor breathing and discomfort to sensitive people. When the AQI is moderate, it causes breathing discomfort to the people with lung disease and asthma, and discomfort to people with heart disease. Children and older adults also get affected here. When air quality index is poor, it causes breathing and discomfort to people on prolonged exposure, and it also causes discomfort to heart disease patients. Okay, and when it is very poor, it causes respiratory illness to all kinds of people on prolonged exposure. It also affect pronounced people with lung and heart diseases. When it is termed as severe, it causes respiratory effects on healthy people and serious health impacts on people with lung and heart diseases. So it affects all kind of people when it isn't severe, when it is deemed to be severe. Okay, so we saw about the various control equipments for controlling air pollutant. Then we saw about the air quality index, and then we also saw about national ambient air quality standards. So in the next video, we'll be seeing about noise pollution and the methods adopted to control this noise pollution. So here we'll end this lecture, and thank you.